Hello internets once again. Here's a little look into my latest project, and before all the internet safety trolls get their undies and bundies, this is just a temporary setup to test my new variable frequency drives here. I got this one in and I should be getting another one in pretty quick here. They're used parts, so it's always good just to bench test them before you get them in a machine. Long term, this will be real shielded wiring. This will be correct wiring with contactor and fuses, and it'll end up in one of my favorite surplus store Axeman's random metal boxes once I close up all the unused holes and figure out how I want them mounted. So unlike most people, I'm actually converting my mill/lathe from single phase to three phase, and the main reason I want to do that is speed control. So if you get one of these fancy little variable frequency drives, you can get them from 110 to step up to 208, or in my case I have a 240 to 208 inverter, but it's taking in single phase on this side and making three phase on this side of just about whatever frequency you want. So as you can see, right now I got it set to 120 Hertz, which should put out double the 1755 this motor normally has. So if I go ahead and hit run, you can see her spin up here. I have a 5-second ramp going up and then a half-second ramp going down, as you can see. The reason for doing that is since this is going on a lathe, you sort of want to spin things up slightly slowly. So if something is out of balance or something, you have time to hit the EPO and shut it down. And the fast stop time is so when something does go bad, instead of slowly coasting to a stop, it just goes bang, and you're there. I may play with those values once I get this in the lathe and all hooked up. The motor is a trash can special. I put a new pair of bearings in it. Over frequencing a non-inverter duty motor, which is what this is, I did a bunch of reading, and most of the internet armchair resources say 1700 RPM motors are a two-pole motor. 90% of the manufacturers out there use all the same bits in a two-pole motor as they do a four-pole motor, which is a 3400 RPM motor. So doubling your frequency on this and going up to 3400 RPM should be perfectly fine. Main things they said to watch out for is check your bearing temperatures, because that's going to be one of the first things to go. And the second thing is watch how much the whole thing shakes. If the rotor's out of balance, it'll just shake itself to bits. As you can hear, there really is no shake to this motor. I mean, if I feel it, I feel just a tiny bit of vibration. So that's pretty good. And when I put new bearings in this, I bought premium Chinese bearings, so they should be good for 3400 RPM. I don't think I'd push it much farther than this. And then the real nice thing about a variable frequency drive is I can sit and crank it to whatever speed I want. So there's 3 Hertz, and as you can see, I mean, there's some balls behind that still. So it's not just, yeah, it spins, but it's not used for anything. The main thing I want to do is get rid of the belt changes. That's one of the most annoying things. This lathe only has, what is it, 7 different speeds. So you get something you're turning and it starts to chatter or do something else bad, and you just want to nudge the speed one way or the other. You either have to shut down, move a belt, and go a whole jump one direction or the other, where now I'll just have a little control that you just, dial it up or dial it down. So that's about all I had. So I need to get my other controller in, test it, mount that and all the rest of the safety equipment in one of those, and then find me a different motor. This motor will work fine for the lathe back here if I make a new bracket, but this motor for the mill has to be a face mount, because the bolts go in, from up above into the face of the motor. So yeah, this will not work. There's just not enough metal in the front of at least this motor to tap holes and hang the whole weight of the motor and take the torque of the motor to its stationary object without just destroying the end bell cap and the bell end. There you go. Okay, that's all I got. Laters.